Tonight is really going to be focused on some updates of things that we're doing in the Water Master Plan. We talked about several of those items when we got together last time. You're going to start to see some connectivity between them, and then also an interesting update on some wildfire modeling that the team has been doing in association with the Board of Water Supply's Risk and Resilience Assessment. This is our plan for the night. Welcome and public comment, BWS updates. We'll talk about changes in water quality regulations and how we're addressing that in the Water Master Plan. Then discuss the condition assessment work that is now starting up as part of the Water Master Plan process. I mentioned the wildfire modeling. We'll wrap up with meeting notes from our last meeting and a review of our upcoming meeting dates. This is the opportunity for public comment on any items on our agenda. Seeing none, we'll move on. BWS updates. As I mentioned, the manager isn't feeling well tonight. Barry or Kathleen, I don't know if there's anything that you wanted to say to the group.
Red Hill's still happening. You've probably seen a lot of articles recently with the restart of the IAEA Halava shaft for the Navy. You probably saw the editorial in the paper this morning from about that issue, and that the editorial staff felt that the Navy needed to be more transparent on what they're doing. On the landfill, there's still 2 bills going through the state legislature, and they'll be going to conference, and it is fully expected that at least one of those bills will survive and get approved. If that happens, that will take out of consideration the site that the mayor identified up at, just north of Wahiwa, and unfortunately will not leave much else because they're not amending Act 73, which we all know is the one that put in all the parameters of where you can site a landfill. So at that point, the city will have to go back and reevaluate what their plans are. So that's pretty much all I have. Any questions?
Well, let's move then into an update on water quality regulations, and I wanted to introduce John Lowry. He works with me at CDM Smith and is heading up this task in the Water Master planning process.
So just a little background, where does this water quality regulation come from? So it all comes down from the Safe Drinking Water Act, and it's implemented on a national level through the US EPA. And the US EPA delegates to the states most of the time, in most of the states, to enforce the regulations. And in Hawaii, that is the Hawaii Department of Health Safe Drinking Water Branch. Generally, Hawaii has adopted EPA standards. There are a few standards for which Hawaii has a little more strict MCLs that have to do with some of the pesticides and herbicides used on the pineapple fields. So first off, we're going to talk about a few regulations. And these aren't all the regulations, but these are sort of the more relevant ones to Hawaii and Oahu specifically. And just some of the ones we're taking a harder look at and making sure that we're in compliance and just tracking any changes that could impact how BWS operations work. So we'll talk about a couple that haven't been revised. We'll talk about revised total coliform rule, lead and copper rule that have been revised, and then we're going to talk about some emerging contaminants. So first of all, these are some regulations that have not changed, but just a little background. The groundwater rule, that one really is for targeting pathogens. You're thinking about E. coli, things that can make you sick. And these kind of go hand in hand. So in order to get rid of those pathogens, the regulation is the disinfection byproduct rule. Through the disinfection process, there's often byproducts created that can also be harmful to human health. So the disinfection byproduct rule sets the MCLs for those byproducts. And like I said, these haven't changed. BWS is in full compliance, but we are just taking another look at that. Some regulations that have changed: the total coliform rule, which is now the revised total coliform rule. And so on the left here, we're talking about sort of what the historically what the rule has targeted. And in the past, it's been really regulating total coliforms, and now they've revised the rule to target E. coli, which is a more specific indicator and a more direct risk to human health. Compliance is still required for all public water systems, but it's more of a, instead of a reactionary type of program, it's more of a expanded to monitoring and corrective actions. And for the MCLs, they've been refined, and treatment techniques have been improved for safety. Instead of, again, like I said, more of a reactionary stance, it's more of a, now there's a sample siting plan requirements that you have to be very specific, and you really have to focus in on areas where you're most likely to see contamination, and those are and that has to be where you draw your samples. And so BWS has developed that sampling plan, and they are in full compliance with these revised requirements.
Just a second, on the you mentioned maximum contaminant levels, or MCLs, a couple times, and my recollection is those are based on health risks, specifically cancer risk?
Well, in this case, for coliforms, it would just be more like a health risk that is likely to cause human illness. The MCLs, depending on the contaminant, it could be cancer risks or other health risks. Yeah. Another big one, you probably heard about this. This really stems from what happened in Michigan a few years ago now, where their water quality changed due to drawing from a new source, and so they had a bunch of lead pipes in their system that were the new water source was more corrosive and caused the release of massive amounts of lead into their system, and so that stimulated new legislation, and that led to the lead and copper rule revision, and then more recently lead and copper rule revision improvements. And so in the past, it was really, similar to the total coliform rule. It was kind of based more on a reaction, sampling for lead, and dealing with the results on a case-by-case basis. But now, given what happened in Michigan, the goal is more to actually target where you have lead in your system and remove it, because you can't necessarily predict when your water quality might change, and that could cause a release of that lead. So that the focus used to be more on corrosion control for lead reduction, and now the focus, like I said, is just to actually get the pipes out of the system. One of the first requirements was to do a service line inventory to just figure out everything that's in your system, both on the publicly owned side, so that is from the water main to the meter box, and then also you have to figure out what's on the private side, so from the meter box to the customer's home. And that's a very daunting task. BWS worked very hard to meet that deadline, which they did, which was October 16th, and there is publicly available information about that on their website. It's really handy. You can actually just put in any address, and it'll tell you what they found. A revised baseline inventory now is due November 1st, 27, and that's really to get rid of unknowns. So as you can imagine, there's a lot of older parts of the system where it wasn't easy to find out what the service line inventory are. Now they have to go back and do more research, potholing, digging up service lines to actually physically see what that material is. And that's due by November 27. And then by November 27 also, you have to have a replacement plan. So anything that's either unknown or known to be lead has to be replaced. And good news for Hawaii is there's been no lead service lines found. There have been some lead on premise plumbing, like interior building plumbing, but that's not in the public water system. Still something that needs to be dealt with. But another aspect to the new LCRR and LCRI is schools and child care facilities. And so this is really to, lead has been shown to be particularly harmful to children and childhood development. So the goal is to really get any potential lead out of the systems that younger children are in on a regular basis. And so these are the requirements. I'm not going to read through them all, but I'll leave the slide up for a moment so you guys can take a look.
I remember growing up, and my dad would always say, well, let the faucet run for a minute before you drink any water. Or, at school, let that fountain run for, I don't know if other people remember that, but that was really driven by these types of occurrences of lead in the system and letting that flush out. So what a different time we're in, I think, for the better in terms of the management of lead in water systems.
So now let's talk about some emerging contaminants. Hexavalent chromium. So hexavalent chromium, it occurs naturally from erosion, and it's also a byproduct of a lot of industrial processes. And right now, there's only a maximum contaminant level goal for total chromium, but hexavalent chromium is particularly more harmful to human health. And so the EPA is currently developing a integrated risk information system assessment for hexavalent chromium, and also noted that California has already set an MCL for hexavalent chromium effective October 1st, 2024. So that's something we're taking a look at here. Another one I'm sure you've all heard of, PFAS, per and polyfluoroalkyl substances. And so what we've learned about PFAS is that it's everywhere, and now we're trying to figure out what to do with it. So it's obviously harmful to human health. The EPA has just recently established the first nationwide legislation regarding PFAS, and the 2026 Water Master Plan will discuss how BWS is addressing PFAS, and I'm also going to give you a little overview of what they're working on right now. April 2024 was when the regulation was set. April 2027 is a deadline for completing initial PFAS monitoring, and BWS is well on their way to completing that monitoring. We actually had a meeting with the labs just a couple days ago. And April 2029, compliance deadline to meet MCLs, and so that gives 5 years. You know, EPA recognizes that this is not going to be an easy task, and so the draft rule actually had the final deadline as 2 years earlier, but they added on a couple of years for compliance. And these are the values, so you can see very low levels of PFAS, some of them bordering on the detection limit of the testing. That's some of the challenges. Probably seen some of the news articles that BWS has detected PFAS in some of their wells. And so they are undergoing a study right now and looking at where they have PFAS and what they need to do to treat that.
Anyone have an analogy for a part per trillion? It's not very much, right?
There is an analogy that's often used about one drop in a Olympic-sized swimming pool, but I saw an interesting article about that, about how you might be surprised to know that Olympic swimming pools are not a standard size. Yeah.
With regard to this PFAS, I read somewhere that there's like hundreds of them, if not thousands of them. And so for them to be setting standards without ever doing tests and finding out the relative differential between how harmful one might be versus another, how can they go generic like that with the variability that's out there?
Yeah, that's a question for someone smarter than me, but I think partly they just have to start somewhere, but there is a lot of research, going on on the federal and state level. And again, that's where the states have more freedom to set more strict standards and do a more in-depth study of the various variations of PFAS.
Yeah, so as John was saying, we have a consultant contract that's looking in detail in PFAS in our sources. Our labs are testing it weekly. We are finding trace amounts below the MCL on about, 8 or so of our sources. And we are gearing up to do a pilot treatment plant at our Ho'ai'ai wells in Waipahu. We are actively working on a portable treatment JC facility, granular activated carbon, at our Ka'amilo wells in Aiea, and to then transition into a permanent treatment plant. So the consultant will design it, and we're going to pursue federal funding or grants to help offset the cost of that. But we are actively addressing PFAS in our system.
So when you talk about these PFAS, that's molecular, that's a chemical, and yet we're reading a lot these days about nano and macro plastic contamination, which I assume is in our water, ubiquitous and everywhere too. To what extent are these two related to each other?
the nanoplastics are something that is more of a physical health risk because it can actually, it can accumulate in your body. But I certainly think that some of the nanoplastics probably also contain PFAS, so they are related in that sense, but not necessarily all the types of nanoplastics out there do necessarily have PFAS, so they overlap, but they're not always connected.
In the newspaper yesterday, they were talking about states that have fluoride added. We're a state that doesn't, but with the new leadership we have these days, is that subject to change?
My understanding, I don't dive into politics too much, but I think that they're more likely to say no, eliminate fluoride. So that is something that Hawaii does not do currently, and there's no reason to think that any changes in the current administration would change that.
It's costly. It is beneficial for dental health, but folks drink like maybe 10% of the water. The other 90% is irrigation, toilet flushing. So we would be spending a lot of money adding fluoride to our water systems with only a 10% potential benefit. So it's not required, but that has been our previous position. The military bases have fluoride in their water, but we don't.
I have a question for you. You mentioned the pilot program to treat, some of the PFAS in the water. What is the efficacy level of the treatment? Is it fairly high, or is it to this date we don't have very high levels of efficacy to kind of bring those levels down?
Yeah, we're trying to take it out. So the two treatment processes are carbon and ion exchange. We have 13 carbon treatment plants, but it's designed to remove trichloropropane, which is remnants from the pineapple industry, and it may compete with sites on the carbon, but so that's what the pilot's going to tell us. What is the most effective treatment process of the two, and look at and cost effective as well. But once it's online, it's meant to remove it all. But yeah, there are like 19,000 different compounds or something of these. Some of them do not get filtered with the carbon, but we're testing for all the ones that we can, and we know where they are. We also are looking at where the sources are from, because it has to come from someplace. And if there is an identified contaminant area, then how can we prevent it from or slow it down from coming into our sources? So it's very comprehensive. It's island-wide, and yeah, we're doing all we can on that.
On slide 13, you were talking about doing your testing and validation to find out E. coli in the water. Is that done through automation, AI, or is that done manually when you do that testing to verify if there's contaminants in the water?
Yeah, it's a physical draw of water.
So it's a physical draw of water.
Yeah.
So
Yes.
when you identified the E. coli at Mahamoi Street up by Tripler, that was identified by an individual testing the water and finding that there was E. coli in the water there in order for you to do the chlorine in order to make the water suitable?
Yeah, I mean, I don't know if someone from BWS wants to answer, but yeah, that's the way that would have been, that would have been a physical measurement.
So when there's a physical measurement of the water and tested by an individual, how many wells do we have, and do we have enough personnel to do that constant checking to see that there is contaminant, and how long of a time period do we have from the time that the contaminant is identified before the water is treated, so that way we can make sure our kupuna have clean water? And the other question I have before you answer is, sorry, before I forget, because I'm kupuna,
Me too.
is once that water is identified as having E. coli, who is responsible for checking the source of where that E. coli is emanating from, so remediation can be done completely, so we don't continue with chlorination of that water at that particular location? Thank you.
It's a requirement from the Department of Health. We test it regularly. I don't know how frequently, but It's frequent. Once we chlorinate all of our sources. 25 years ago, we used to only chlorinate like 60% because we felt we didn't need to. But as testing methods got better, we just said we're chlorinating everything. When we find, say we do find an E. coli hit, we take it back to the source. That's a requirement. And then we check the chlorinator, make sure that's working. Sometimes it's, it may have run out of chlorine. So anyway, and then if it becomes a violation, if we test a second time and it's a positive, then, and it happened in Windward, then we are required to ramp up our treatment processes and stuff. So it's all regulated. It's not supposed to happen, but I guess it does periodically. I don't know what, I'm not familiar with the Mahoe. Yeah, I'm not familiar about that particular area, but we do test it regularly, and that's our lab technicians, because it's a compliance monitoring. It's it's all hands on deck. Right. We certainly could use more staff, but the staff they do have are focused on compliance.
So from the time frame that is identified as having a contaminant, how much time are we allowed legally to make sure that that water and that source has been resolved? Is there a time frame for that? Because I have my Hanai parents live up there by Tripler,
yeah.
And in December of last year, there were a couple of episodes in that area around Tripler where there were either the wells had contamination up at Tripler. There was so it's saying to me that in the Red Hill area of Mauna Loa, there are problems there. So I just wanted to find out if that source for E. coli has been identified already, or are we just continuing to chlorinate the water without finding where that source is coming from? Thank you.
Yeah, we'll check and get back to you. 'Cause I don't know.
Yeah, there's a very detailed site. That was one of the new requirements, is this site sampling plan, which is really geared towards looking at all potential sources. And so Mark was just telling me how he was sending me the data, and it's a very large list of sample sites. But yeah, we can get you more information about the details.
So
Yes.
E. coli is a fecal coliform indicator and a pathogen, or could be. Some of them live very well in our intestines and help us out.
Yes.
But but the Department of Health in testing ocean water uses Clostridium because E. coli is so ubiquitous. It could be caused by a mongoose or who knows what. It's everywhere. And I'm surprised that E. coli is still the standard. I think you were talking about national standards, but there's an awful lot of fecal coliform bacteria that are pathogenic, and maybe there's better indicators these days. That's all.
Yeah, and the tests do get more specific, down to the source of the E. coli and fecal coliform, depending on. Yeah.
Can you hear? Okay.
Yes.
One is about coliform, and the other one is about chemicals. I'm happy to see there's more testing for PFAs and other contaminants. I was wondering, do we have a plan for disposal of the spent carbon or whatever is that the studies come out for treating these kinds of chemicals? That's the first question.
Yes.
Second question is that a coliform could come from sources of water that are held in tanks, and how frequently do we clean the tanks so that the coliform buildup doesn't happen or is minimized?
That's a separate part of our analysis for the water master plan, actually, is looking at all the storage tanks and the water age and that kind of stuff. So I believe that'll be discussed at a future meeting.
The spent carbon or whatever else is used.
Yeah,
to
so that's
remove
actually the
PFAS.
last bullet point here. That's something that's being studied when they say evaluating residuals management. So looking at what do we do with now we have PFAS contaminated carbon. So what do we do with that? And that's definitely part of the process of making sure it doesn't get back into the environment.
I remember we used to test about like 18,000 samples a year. Now it's 30,000. But when you add the PFAS on top of that, it's even more now. So that's how many tests we do annually. We chlorinate at the source. So it's chlorinated as soon as it comes out of the pump station. And then when it gets into the reservoir in the tanks, it's chlorinated. So
It's interesting on the chlorination part, right, that back in the day, 60%, and now it's 100%. Is that because the water source became more polluted? Is it a societal bacteria-free, everybody use hand sanitizer? You kind of get my point, a cultural thing. Or was it a scientific thing? So I guess that's first, because I'm trying to understand the ethos a little, especially as we talk about other contaminants and what, how we approach them, and right, because I'm sure in meeting 10 of this, we are going to talk about resource allocation of BWS and other things.
So a little bit of big picture perspective, the chlorination of public water systems is one of the most significant advancements in the protection of public health that's ever occurred in human history. There was, if you go back prior to water treatment, prior to water system chlorination, waterborne diseases were one of the leading causes of human death and illness.
Sure.
So from that perspective, I think it's very much an ethos that it's the right thing to do, because to not would be to risk a death that would be totally preventable.
Okay.
So I'd put,
I guess we think here, our water is clean. And did we have cases back then that were unidentified, they weren't measured? So that's fine, I'm
Yeah.
gonna stop there. With the PFAS, right, you folks are testing, and then from the health aspect, right, how much water we consume, I guess trying to weigh a couple things that have been said of, right, your graph of everything it's in, right? I use a Teflon pan. I eat microwave popcorn. So for a human being, if you were to pull blood from me and see how much PFAS I had, how much of it came from water I drank from BWS, and how much actually came from my Teflon pan and my popcorn. And then, how is that going to relate? Because my worry is we look at it from a scientific standpoint and understanding where the actual data shows we consume it from, so that there is not misinformation for people to use this as a public policy weapon, if you know what I mean.
Yeah, I mean, I think, that's why, it's in the word, emerging contaminant. I think everyone's trying to figure it out. But that's a very good point. Like, we've all been, those of us that are older, remember probably all the little chunks coming off the pan and while you were cooking on it and didn't even think about what, it was just the miracle pan that was nonstick. And then, I grew up in the Pacific Northwest and using all the Gore-Tex. So it was on everything. And so, now I don't know that there's a good answer to your question, but the goal is to figure out where it is and treat it where we can, where we know we're consuming it. And so obviously it's gotten out of a lot of the products, but the harder part is getting down to these levels where it's in our drinking water, because we all need the drinking water.
And I just ask you, so
Yeah.
as long as it's a data-led,
Yeah.
scientifically proven way, that it's not, we're gonna take it out of all of our water, and interesting, right? You don't do fluoride because only 10% is consumed by water, and yet you're going to do PFAS removal for all of
I
that
think
water
that-
that
yeah,
goes
w-
into ag, which I'm not saying is not a good idea, by the way.
Yeah.
But just listening to the logic of it, and then really, where is the consumption in a human perspective? That's all.
And
And
that-
then making those cost-benefit analysis and decisions.
The component where we know it bioaccumulates, that's one of the trickier parts of this one. It's like you have to set, some might argue the safe level is 0. Right? So any sort of reduction in your intake is helpful because of that bioaccumulation component. Yeah.
And I would agree with you, I just think 0 in an industrial world is in anything we
Yes,
do
that's-
in life
Yes.
is difficult.
Pono, I think from a philosophical perspective, you're asking really important questions, right? And your reference to all the different things that we're exposed to in an industrial society is spot on, right? Let's then put that in the context of what does a water utility deal with, right? So EPA is responsible for setting these maximum contaminant levels for hosts of, different families of contaminants. PFAS is among the newest of them, where there's regulations formed, obviously at very small concentrations. Those are based on health risk evaluations that were conducted, peer-reviewed, and then they went through the rulemaking process and set the standard and then said to all water utilities, thou shalt comply with this. And so that's the reality of the rulemaking process for water utilities in the United States. And I think the industry argues forever about the cost benefit of those things. And could I do something else with that money and my particular utility that would have a bigger bang for buck? But that flexibility doesn't exist in the regulatory environment. So,
Can they stop manufacturing that? Can we stop bringing it on this island so that we can just deal with the finite amount that's here? But nobody can answer that because it's in a whole lot of products. But maybe one day they will.
BWS is currently working on, so this kind of goes back to what Barry mentioned, but there's development of a framework for strategic decision making around PFAS, and then they are doing the island-wide risk screening and also researching and identifying potential federal funding sources. These aren't actual rules, but they are something that we take a look at. There's the contaminant candidate list, and that's a list of contaminants that are known or likely to occur in public water systems, but they're not currently regulated by the EPA. So PFAS was on this list, quite a while ago, and now there's other contaminants that always looking at, as technology gets better and we're better at detecting stuff, what could be something else we're missing. Available, and it's available on the EPA website, updated every 5 years, and they're currently working on CCL 6. And then out of that contaminant list comes the unregulated contaminant monitoring rule, and then that's used to actually start collecting more data on these potential emerging contaminants.
Got to have a question.
Yeah.
Honor all
was
that
done.
great information. So the EPA sets standards, but could our State Department of Health create standards that were enforceable here that have a higher standard?
They
than
do,
federal?
yeah, they can, and they have. DBBR, and then there's another one. There's a few that they have set a higher standard at. And yeah, states are they just can't be less stringent than the EPA, but certainly can be more stringent.
With all the water utilities across the nation, is there any R&D being conducted to determine if there are remote capabilities to do that testing? Because if we have a finite number of employees to do testing for so many wells, and there is technology out there that could do the testing remotely to give you indicators that there is a contaminant in the water, we're not going to spend a week later to test the water to find out that there could have been E. coli there. We can know instantly if there's a red flag by the AI technology. Is Board of Water Supply doing any kind of R&D to find out if any of the water utilities across the nation or internationally have something in place that we could utilize or do as a pilot program for the state of Hawaii? And before I stop, because I don't want to forget, is this being done equally for all the islands in the island chain? Thank you.
So it depends on the contaminant, and so like something like E. coli, fecal coliform, you're going to have to get that grab sample and do a culture. So there are definitely contaminants that you can live monitor, and there's equipment that can detect that, and that is being done. That's part of what we do during this process of updating the Water Master Plan is looking at on a national level, and certainly in California we look at what they're doing because they're usually on sort of the leading edge. As far as what's being done on other islands, they are all islands have their separate independent water systems that are run separately, independently. So I can't really speak to that.
But they're all subject to exactly the same standards.
That's a good point. Yeah, they are all subject to the same EPA standards.
Are you seeing with this administration, attempts to roll back, have EPA roll back standards, minimum standards with respect to the Clean Water Act? And even in the historical context of states being able to do more stringent things, are they potentially trying to couple some restrictions on the states in that regard? Or so far, have we not seen any effort to, limit states' ability to be more stringent, even if EPA gets pressured in this administration to roll back standards?
Yeah, we're certainly taking a very close look at that. I have been involved in some projects where there have been efforts to actually, as a project that we're doing for the EPA in California, and that we were told that there were some efforts to scale back or cancel some of their efforts for compliance with the lead and copper rule. So far, they were able to push back and continue with that work. I feel like the administration, one of the things they tout is that they want the states to have the freedom to do what they want. So I don't think they're going to get down to that level of telling states they have to be less stringent. But as far as on the national regs, I mean, it's definitely something we're taking a close look at.
My question is the accumulation. For historical data, are we looking at historical data to see how the accumulation of pesticides from when we had sugarcane and pineapple, how that is going and saturating and getting down to the aquifer? Do we have data on that? Because if we're proactive now, we could eliminate some of the different issues before it saturates down to or gets down to the aquifer.
For sure, that was actually part of another project, the source water protection plan that we actually recently completed for BWS, and that's definitely something that was looked at. The person that was leading that is sitting in the back of the room, but it's definitely an issue that's being looked at specifically. Yeah.
So the issues of heptachlor that we experienced in the 80s at the elementary schools and the milk and everything like that, that won't become more prevalent as years go by because of that actually getting down to the aquifer from the soil.
Well, I can't say for sure, but I can say they've stopped at least applying the chemicals to the soil. So, but it's also something that we're keeping a close eye on and definitely studying and how those contaminants continue to move throughout the system.
Yeah, we're not finding any heptachlor in our system. The UCMR, by the way, it's on the 5th version, so they keep adding more stuff to test for. Like TCP is very persistent in the environment. Yeah, if you think of if you apply a pesticide, you want the thing to be effective. I don't want to keep applying, so the chemical is very stable, so it was very effective as a pesticide. But that kind of pesticide doesn't decrease in the environment. We've been treating TCP since the 1980s. 45 years, and the level's not going down. Eventually, I figured the thing is going down, but it's not. So yeah, it's those kinds of, at least for that particular chemical, it's there, and it doesn't look like it's getting any lower.
Chicky, I wanted to let you know we do have 13 granulated activated carbon centers that, as Barry pointed out, that we actually use for filtering for chemicals due to sugar and pineapple, as Barry just talked about. So we actually are doing that already.
Next up is Carl London. Carl is going to be talking about how we're going about assessing the condition of different BWS facilities, and that becomes a really important part. Understanding the condition of those facilities becomes a really important part of developing a capital improvement program. That's a critical part of the Water Master Plan process, and so that condition assessment is really foundational to how we go about doing that. And with that, I'll turn it over to Carl.
What we're going to talk about today, first reviewing how the condition assessment was done in the 2016 Water Master Plan. That condition assessment effort was done mostly over 2014 and 2015. We're going to talk about some accomplishments and some of the changes that have happened since 2016, so from then to now. Our plan for condition assessment for the Water Master Plan update, and then give everybody a timeline of where we're heading in the next couple of years coming back to you. Overall, BWS infrastructure, where it is on the island. What I'm going to focus in on here is how we did the assessment for each of these types of infrastructure. So starting over here on the top left, looking at the wells, the pumps, the treatment facilities, and the offices and base yards. Those were all done as a visual inspection. Moving over to the right, the potable water reservoir, all those tanks, there's 172 of them. All of those got external physical inspections, some internal visual and structural assessments. And then pipeline, we looked at statistical analysis, forensic, and physical inspections. So I'm going to dive a little bit more detail to each of these. So I'm going to kind of go through in each infrastructure type. So first, pipelines. So in 2016, the inspection methods we used, first, statistical, 2,600 miles or 2,100 miles of pipeline in the system. Obviously, we can't go look at all of it. The statistical modeling, it's using big data. It's using all the GIS data that we had. Board of Water Supply has done a great job since the 70s keeping main break data. So that's a really fantastic treasure trove of information. So we take all these data sources, put them together, let the computers do some math on it, and it helps identify likelihood of failure for every pipe segment in the system. The second part was forensic. What we would do is either a pipe that was coming out for some other reason, if it had a break on it, or just a pipe that was interesting for some reason that was coming out of the ground. We'd take it, get it sandblasted, and look at how the corrosion was happening on that pipe. So that could sort of ground check the statistical modeling, provide some input to that. Physical, so we did do some internal pipe inspections. There was a couple of tools we looked at. If you remember back, one's called Sierra. It's a camera that's on a tether that goes inside the pipe. And it has some electromagnetic sensors on it. Another one is called Smart Ball. It's kind of a similar type of sensor, but it has basically a Nerf ball around it, and it just free floats through the pipe. You put it in on one side, and you catch it at the end. And then also some acoustical assessments as well. So there you put hydrophones along the pipe, run a sound wave through the pipe, and listen to changes in sound waves as it goes through. So tested all of those out. Those can be done on much fewer segments of pipe. Just it's a lot more effort and a lot more cost to do that testing. So again, we are looking for specific places to test that. What did we find in 2016? This is the number of breaks on the y-axis. On the x-axis is over time. All the yellow little dots is each year's number of main breaks, and this is main breaks and leaks. BWS combines those, at least has historically. We're starting to tease them apart a little bit, but breaks and leaks. And the yellow line is just the 5-year running average, so kind of smooth out the data a little bit. So what did we learn from 2016? Main breaks were generally trending down just above 300 breaks per year, 2014, 2015 when we were first doing this analysis. But then when we put together the statistical analysis, we saw some different things. So here in the dotted line, so this is a bound. This is zero replacement. So this is just telling us what's, if we weren't replacing any pipe, what would happen? And it showed that breaks would go up, unsurprisingly. The dashed line is the status quo. So at the time, pipe replacements were averaging about 6 miles per year. So if we just continued at that, what would it look like? And then the blue line is actually what ended up being the scenario that was selected for programming into the capital improvement program. And that was about 10-year ramp up to 21 miles per year. So that's 1% of the pipe per year getting replaced. That was the scenario that was programmed into the CIP. So what has happened since? We added a few more dots on here through 2025. I think everybody knows there's been some headwinds to getting to that 21 miles, running behind a bit, doing what's possible, but it has been some difficult there. And I guess it validates a little bit some of the statistical modeling we've been running kind of in between the 6-mile status quo and the 21-mile ramp up. Those breaks are shooting about where we would expect it to do. So a little bit of noise in there, but so it's validating some of the modeling at least, and we know where we're going. One thing that has changed since 2016 is a lot more focus on the satellite leak detection. That's working really well, and really helping to identify areas to go find leaks, to go find breaks, and hopefully get to those leaks before they turn into breaks.
So those main breaks, where do they occur? Is there a pattern of where that's actually occurring? Are we able to delineate where that is? And a lot of those breaks, are they happening along the area where there is the area that's being developed by an above-ground transportation system? And if so, and if that's what's causing the breaks because of impact or whatever they're doing to the soil in order to create those pillars, who's responsible for paying for that replacement of that piping? Does that go to the taxpayer, or does that go back to that entity that is building transportation above the ground?
The first half of where they're occurring, that was a big part of the statistical modeling, looking at pipe materials, installed date, how it was installed, what the soil type is, whether it's sitting in salt water, all these things. And the answer is, it really depends. There is clear metrics that do impact the likelihood of a pipe failure. So if you have a ductile iron pipe in well-drained soil that has already been installed for quite a long time, the likelihood is that pipe is going to continue to be just fine. You see a lot of breaks when pipes are first installed, just like a lot of things, right? Like when something new is built, the early failures, you'll get a couple of early failures until those get fixed, and then all the weak points are taken out of the system. If you have metal pipe that's really low, so it's as chlorides are coming up, especially right near the coastlines, those are corroding more. So there was definitely some correlations that we were able to use to look at to assess the likelihood.
If you're asking, is there a part of the island that there's more main breaks? I don't know that you could say that one part suffers more main breaks than others, to be honest with you. We do go through spates, apparently, where we'll get a lot on the windward side, and then we won't get any for a long time, and then we'll get some on the north shore, and we won't get any for a long time. So if they did a distribution of our main breaks, it'd probably be kind of all over, but probably more in town just because of density and things, and the pipes tend to be older. To the second part of your question about a rail, yes, we've had some main breaks on rail, but it's been due to contractor error for the most part versus anything they've done with the work. And we've noticed it's happened more frequently as they're coming down Dillingham. So I'm not trying to point fingers at anybody, it's just a reality. It's just, we had one not too long ago. There are a lot of utilities. Dillingham is an old corridor. Lots of work has been done over the years. And sometimes things aren't where they're supposed to be. Maps change and people don't necessarily update the GIS maps. So we've had a few hits on our main, but they fix it and they pay for it. We do not pay for it. The taxpayers do not pay for it. Or not, actually, our ratepayers, not taxpayers.
Okay, thank you.
Are you cranking into this work programs to prevent or minimize the occurrence of main breaks? I know Board of Water Supply already has internally, but the technology gets better, so.
Yeah, for sure, and that's we are continuously looking at, as technology changes. The satellite leak detection is a big one of those. We were doing the pipe assessments, and in reality, I think we found that in specific circumstances, it's helpful to assess a pipe, but most of the time, not really. The satellite works pretty well, seeing that leak before it turns into a full-blown break. As far as decreasing the potential for breaks, absolutely. That's really more, though, about changing how pipe is installed. So unfortunately, there's not much we can do for pipes that are already in the ground. The Water System Ops does do a good job of doing things like minimizing pump cycling, pressure spikes in the system, trying to keep the water flowing smoothly and gently to not cause breaks. And that's really the biggest draw. If you look at if I ran this out further back into the 70s, it was even higher. This decrease here is really due, we think, mostly to changes in operation, doing a better job of not surging pumps and things like that.
The Mapudapuna area of Honolulu is sitting in salt water most of the time. So is there any way to mitigate that?
With the pipes that are installed, probably not too much. That's going to be looking at, in the future, what are we going what are we going to get to? Actually, it's a
Salt-resistant metal. Is there something?
yeah, there it is, right? And that is one of the things that we're looking at in this iteration of the master plan. You helped me with my segue perfectly. Is overlaying the climate and sea level changes and vulnerability changes in the next, that are going to happen in the next 100 years. So Mapunapuna in Ivalai, yes, all that salt water is going to come up. So anything that's in there that's a metallic pipe is going to be in rough shape. So then it becomes coordinating with other utilities. What are the changes that are going to happen in those areas? Raising roads, raising utilities, corrosion-resistant material, all these things. It's going to be a all hands-on-deck situation there.
We also changed our standards from the last master plan, so we've added cathodic protection requirements in our standards for ductile iron, trying to keep the corrosion level down. Ernie insisted that our cast iron pipes are epoxy coated now, so that's an extra step. It adds more cost to it. And we also have guidelines, I guess, when we install PVC pipe in saltwater environments, 12 inches in diameter and lower. Yeah, because they don't corrode, but PVC is very delicate. You got to put them in right. You cannot bend them. They get brittle after that. And then when the cities in our One Water Honolulu plan, we're looking at these inundated areas and trying to figure out, okay, when do we start elevating streets? And when the city starts to elevate the street, then we'll replace those pipes. But if we replace them now, and then they elevate the street, they get too deep and we can't reach them. So we have to wait until collectively, but we're identifying these vulnerability areas and looking at wastewater, stormwater, and freshwater, and access altogether. So that is I think that's a presentation that we should do eventually.
Talk a little bit about reservoirs now. All right, so what we did in 2016 inspection methods. First, we went around to all of the tanks, 168. I guess there's a couple that were currently in construction or about to be replaced, so we didn't inspect those. But and this was external, non-destructive physical testing. So it's called sounding, rubbing the outside of the tank with a hammer. You can hear the sound change, inspecting the seals, inspecting hatches and locks and everything around the tank. On 30 tanks, we did submersible ROV, remotely operated vehicle, those little submarines with cameras on them, doing internal visual inspections of the tanks. And then we did structural analysis on each type of tank. So there's actually only 10 or 13 different structural types of tanks. So we were able to just look at each of those types and look at how they would resist a current code level wind or seismic event. So what did we find? 94% of the tanks were needed no or minor work. Were in good shape. Did identify 7 high priority projects that went into the CIP as high priority projects. Where there were repairs that were needed, they tended to look like this: foundation slabs and seals. This is the foundation of the tank, and then the wall, and there's a seal in between. So here you can see that seal is starting to fail. And once it starts to fail, water gets there, plants like the water, and then they start making it worse. Leaks through the walls, spalled concrete, meaning there's air behind the first layer of concrete.
I'm just wondering, when you investigated all the 160 tanks, did you look at, when water is in a tank for a while, dust comes in through the little slots, and it builds up as sediment around the bottom, which becomes a source for coliform and other things. And I'm wondering whether there's more cost effectiveness to clean the tanks every 5 years, 32 tanks a year, or add lots more chlorine to bring it up to a clean level. So I don't know. They probably made that assessment some time ago, Irwin and somebody, but I just think cleaning the tanks would make me feel more comfortable.
The answer is yes. They do have to inspect the tanks I'm probably going to quote it wrong. I think it's a little bit different in each state. It's usually every 3 years has to be inspected. Most utilities clean at that point too. There is a program to make sure that that's in the bottom of a tank. The outlet has a silt ring on it to make sure that silt doesn't get out. And every once in a while you go through and clean them out. So yes, that happens. And then the other side of it also is keeping the chlorine residual in the tank so that if a pathogen does get into the tank, right? The air has to come in and out of the tank, so there is going to be pathogens that are able to get in, that it is neutralized by the chlorine residual that's in the tank. So it's definitely a multi-approach doing both. So since 2016, all 7 of those tanks that had high priority projects are either completed or currently a couple of them that were done here. And so going forward, what are we looking at? As we update here, one of the big things is calibrating how we understand the rate of decay happens on these tanks. If we do a single condition assessment, we say, okay, this is what the condition of the tank is today. It doesn't tell us how long we have to be able to do the project to maintain it. If there's a small section of spalled concrete, is that going to be fine for 10 years? Is it going to be fine for 30 years? Is it going to be fine for 1 year? That's good to know because it helps with programming. So there were some tanks that were done back in 2005. So this is an example here. So this picture is from back in 2005. This is when we did the inspection in 2014. So just here you can see there's a couple differences, like we've got a little bit of growth coming out of the top seal. You see some vegetation growing down here. That probably means the bottom seal has a little bit of a leak in it. So that amount of time, that tells us, okay, 9 years, this is what changes. Well, now we can go back through and look at some of the tanks that we were worried about in 2014 and kind of calibrate that rate of decay. Now we have a longer span of time to say, okay, how long can these tanks last at each condition assessment? The second part is evaluating the success of the repairs. Again, a bunch of the repairs have been done. How well did it work? How much effort was it? Lessons learned from that as we're programming new projects. And then looking at some innovative inspection methods. Like I mentioned, we went around to every tank. It took at least half a day per tank to be able to do that physical inspection. So there's some tools that can help us with that now. Get these inspections done at a more frequent basis and for lower level of effort. So these pictures are not BWS infrastructure, but one of the things that we can do is fly a drone around the tank. The cameras and the remote sensing have gotten really good. So on this bottom right, a visual camera looking at tanks, it can get you really quickly to a spot where you can do a visual inspection of the tank, from the ground, not having to get up in bucket trucks, safety thing, and also be able to do it more quickly and get closer to spots where you want to see it. And secondly, so that's kind of similar to what we can do from a bucket truck. What we cannot do from a bucket truck is the top right image is things like thermal cameras or different wavelengths. This tank, you can actually see, this is actually the recent high water level, the recent low water level. You can see where it's cycling in there. But what's actually more interesting are things like this cold spot down here on the bottom is probably a leak. It could be a section of spalled concrete. So this zeroes us in on knowing where to go look. What we want to do in this round is take some of these drone footage and correlate that with the physical inspection that we do. If we get good correlation there, then we can start using the drones a lot more to do those inspections at a much either higher frequency, lower level of effort, and be able to do more. The other facilities I'm going to talk a little bit more briefly about. It's really visual inspections, and I don't want to say straightforward, but a little more straightforward. It's looking at pumps, it's looking at the treatment vessels, assessing where things are corroded, broken, non-functional. That was all done in 2016. Those projects got programmed into the master plan over the years since. Most have been completed. And so that process is continuing. That's just going to be a continuous process. You're seeing a pattern of one of the big things we're looking for with this master plan update is overlaying vulnerability assessments for climate and other vulnerabilities. So taking a look at those pump stations and saying, where are they at? Do they need to move? Are they going to be there for the next 50 to 100 years? And same with treatment systems. Treatment systems is another layer on top of that, is looking at, as John mentioned, the changing regulations. And I think I mentioned this enough already, but yeah, overlaying, as these climate changes and what is the impact to the infrastructure, and how can we adapt from that?
In the past, when we talked about delivery, one of the big items was generators. Are generators part of your purview, and what's the status?
Yeah, so that was one of the things we did in the last master plan, was an assessment on the generators. Identified 3 sites that could use permanent ones. Those have been done, they're installed now. There are still a bunch of portable generators, so we'll revise that assessment as well with the new permanent generators, the new and all the portable ones, and make sure that we still have the reliability that's needed based on those. But we'll probably identify another couple sites.
Let me be more specific. Is there any redundancy, or are we still POHO?
Yes, there is redundancy. There is. So one of the things we looked at is the total volume of water that can be produced on emergency power, and making sure that that was enough to meet people's indoor needs. So that's where the 3 generator projects came from, to get us to the point that that was met. Not necessarily entirely, some people might have to drive for water, but there would be enough volume pumped to keep people drinking.
Except,
Is photovoltaic being considered as a source for energy in order to power the generators or provide power for the pumps? With that surface space above the tanks, is photovoltaic being entertained as a possibility as a power resource? And besides photovoltaic, is there a possibility of there being a wind turbine or that kind of technology, since a lot of the elevation for those tanks are in a wind environment?
In 2016, we started a energy savings performance contract. You talked specifically about PV. Well, let me just speak a little bit more broadly. That particular project was looking to find a way to save energy for the department so that we don't spend as much to HECO. We basically gave the companies, these energy service companies, a blank sheet of paper saying, do whatever you need to do to tell us how we're going to save this much electricity, this much money. As you'd expect, they went for all the low-hanging fruit. They changed out the lights to LED lights when we used to have just fluorescent lights. Changed out some of the older equipment, AC equipment, so that's more efficient. Changed out a few well pumps. Changed some of the controls that we have at our well stations. But PV, as you expect, yes, definitely look at PV. So we do have PV at about a couple dozen of our sites. We have it on top of our reservoirs. We have some on the ground level. And if you drive by our Beretania office, you'll see that we have carports where we have PV systems over our parking lots. Makes it nice and cool when we park there. To your question of whether it can actually run our pumps, unfortunately, you need a lot of PV to go and run our pumps. The motors just take a lot of energy. We'd love to have it do it, granted. We just don't have that area. But it does help offset what we might need. And when the pumps aren't running, because they don't always run all day long, we've happened to get in at a time when we could get the TM rates, or the TM program that HECO had, so that we're basically selling it back to HECO at a pretty good price. So for those reasons, yeah. On a longer term, is there going to be another project? We don't have one in the books right now to do any more PV, but we're running with this one to see how it's going. Oh, to continue on with the ESPC project, the idea is that you have this company build all these different types of energy conservation measures, and then they have to guarantee that these savings happen over the course of 17 more years. And so that's effectively, if you do from the accounting standpoint, you can show that we put all this infrastructure in for no cost to the Board of Water Supply. And then after those 17 years, we continue to reap those benefits and all the savings from all that energy stuff that they put in there. So that's what we have right now. But yeah, just thinking about how much energy we can actually get from PV at our sites, it's unfortunately not enough to go ahead and run any of our motors to run the wells. But it does help offset it.
Thank you.
Wildfire emergency planning. So the first thing I want to do is I want to remind everyone, back in July 2024, Ernie went ahead and presented on the Hawaiian Electric's Public Safety Power Shutoff Plan. So just continuing the conversation, just remember this is an ongoing effort between HECO, Hawaii Wildfire Management Org, and BWS. So first, let's get it into everybody's head, the kind of wildfire we're talking about, right? We're talking about the Lahaina fire. We're talking about the recent LA fires as well. I'm sure everyone knows Lahaina fire, deadliest U.S. wildfire in 100 years, 2,000 plus structures, 100 plus deaths, 70 mile per hour winds. Similarly, in LA, severe drought, the driest 9 month on record. You had 2 separate fires going on at the same time. The Eaton fire, the Palisades fire. They were, I don't know, either side of Los Angeles, east side, west side. 16,000 structures destroyed across both fires. 25 deaths. Very catastrophic. These are the types of events we're talking about, right? Very extreme, but they are more prevalent nowadays. They're occurring more frequently.
If you look in the detail, you can see the burned wildland areas up here, right? And then when you look as it moves down into the urban interface, you can see that there's a lot of still green vegetation and some structures standing.
Mm-hmm.
And then you get down to right along the beach, and every structure along the beach is gone. And what that's a result of is not direct contact ignition. It's embers coming off of the wildland areas, blowing out ahead, and then igniting a new front out in front of where the actual flames are. And so this is a really interesting photo that really demonstrates that mechanism very clearly. So I just wanted to point that out.
Yeah, and what Dave's talking about, we call it urban conflagration, right? These very extreme 70 plus mile per hour winds, they're pushing these embers out past, like Dave's saying, could go miles. And it's igniting these homes. Speaking about that urban wildland interface, you got the burned area on the top right over there. You have all of the burned developed area down there. And like Dave was saying, I'm sure a lot of people in Los Angeles have driven through this area, but there are pockets where there are homes still standing in the middle of all this destruction. So it's really just these embers, these high winds pushing these embers far out. And I just want to highlight that definition at the bottom because we're going to talk about that a lot during these slides. Urban conflagration, building to building spread through embers carried by extreme winds. So just keep that in mind, conflagration. Okay, so I want to highlight a couple of these good quotes from multiple people. It was actual firefighters battling these fires, water system operators, and different residents that were there experiencing these. So some challenges on the water system. I think first, let's highlight the urban system was never designed for fighting these extreme wildland fires. They're designed to treat or to address smaller problems, home fires. Simple, right? But quote, simple. So the pump's running, but the system continues to be depressurized. Many properties, water was spewing from melting pipes. That's a quote from the Lahaina fire responders and water operators. In Los Angeles, no power was lost to LADWP. Pumps continued to run, but the extreme demand on the system still depressurized and reduced water in the tanks. The need to maintain pumping capability kind of makes it difficult when we're talking about power shutoffs in an area. How are you going to fight the fire, pump water into the system if there's no power? Not only the actual urban system, but let's take another look through the eyes of the firefighters' response issues. Not only did the wind fuel the blaze, it made it impossible to launch the aerial support, which is common for a lot of wildfires. But in these extreme scenarios, 70 mile per hour winds, nothing's flying. Nothing's getting up there. When hydrants run dry, water tankers may have access issues. I think you should have seen it on the news. It was common. There was cars abandoned on the only entrance exit, or one of the only entrance exits into the Palisades area. And yeah, cars are blocked. People are trying to flee, but at the same time, you have firefighters responding, trying to get to the area, and it's just a mess. It gets complicated. Firefighting crews were stretched thin as they battled 3 different conflagrations on the island. This was Lahaina, but same case for Los Angeles. 2 different fires, huge. Well, actually more. There was 2 huge fires, a couple smaller ones. Firefighters are spread thin, trying to respond to everything. Okay, that's setting the picture, right? These are the extreme events we're talking about. Now, let's talk about what does BWS have in place right now to try and address these extreme scenarios. I'll give the example of a fire hose, 150 gallons per minute, average is what it runs, and a typical water tanker, 3,000 gallons, okay? So right now, the BWS system is designed to address fires in each of these different, let's call them areas: residential, low density, high density, and then you have big industries, hospitals, industrial, et cetera. So on a typical, single family home, they need to run 1,000 gallons per minute for an hour, which equates to 20 tankers or 6 to 7 fire hoses. Residential, multifamily, 10 hoses, 30 tankers, et cetera, et cetera. So they actually are able to address big demands on the system, but in the case of these urban conflagration events, it's an even greater demand than this, if you can imagine that.
So before you go on, it's either or some combination of those two. It's not 6 to 7 hoses going full bore plus 20 tankers,
Correct.
right? So that's one thing. And then those water system, the fire flow criteria, those are generally established by the American Water Works Association and are uniform really around the country. Mm-hmm. So this isn't, BWS isn't special in these. This is what is typically done in water systems all through the country.
Correct. In addition to what the demand can handle, they also do have some infrastructure in place right now to address wildland fires. Specifically, the emergency connections and pads for the dip tanks, which is what you see in the image right here. They're exactly that. They're meant as a way for BWS tanks or pumps to fill up these portable steel tanks here on an emergency basis for helicopters to come in and scoop up water, take it out to the wildland, and try and address the fire. Again, I think just a reminder too, these extreme events, there's no aerial support typically. It's just BWS does have these in place right now. There's also proposed sites they're working through with HFD right now and where else they need support, so they're working on it. As well as the physical infrastructure, they are, again, going back to the first slide I brought up, they are meeting with HWMO and HECO right now, talking about power safety.
Mike, got a quick question. I live up in Mililani-Mauka, and in November of 2023, we had the Mililani-Mauka fires. Mm-hmm. And the helicopters and all the support crew were going over there by Mililani Middle School. They had an area, a pond that they had created to get the water and then try to put out the fire. And so with technology happening and with what Amazon is doing with delivering packages with drones and things of that nature, my biggest concern was the helicopters, big helicopters, military helicopters were going over the community, going over the schools. And I was just wondering if Board of Water Supply or the fire department's looking at drone technology, because if Amazon is doing things where they're looking at doing deliveries with high and heavy drones, and if you can program a drone to create King Kong climbing up the Empire State Building in a fashion where it looked like an actual figure, can't something be done with drone technology where you could have drone technology to pick up the water, get closer to the fire, and then not put the pilots and aerial people and of course the residents area in jeopardy? Because if a drone crashes, minimal impact to the community as opposed to a helicopter.
So a couple of things. I don't believe we quite have the drone. We're using drones at BWS, but we do use companies that use drones when we use drones. HFD has a very robust drone program that they've had in place now for several years. That's an interesting concept about drones carrying water. A gallon of water weighs 8 pounds. Water is very heavy. So, yeah, that's an interesting concept. I don't know if Barry has anything he wants to add, but.
Well, what I was going to say is a helicopter like this carries about 2,500 gallons of water.
Yeah.
Or less. And so if you multiply that, as Kathleen said, 8.5 pounds per gallon of water, let's say it's 2,000 gallons, now we're talking over 16,000 pounds.
Yeah, you need a very big drone.
Right.
But did you guys see the news the other day about that weather balloon thing that was flying around the island? Okay, so there's this technology out of South Dakota, And they have these balloons that can actually be stationary. And one of the things they're talking about was using this technology during a wildfire so the guys on the ground, through their phone or iPad, can see where the fire is spreading. So that's another way to use drones in fire technology and help you maybe get ahead of the fire with doing fire break stuff. I thought that was really interesting.
Just the other, I'm thinking through your question because I think it's a fascinating question. The other thing, if you can't fly a helicopter or an airplane, there's no way you can fly a drone. It's too windy, right? They're just going to blow off course. Uncontrollable.
Just wondering if they could get even closer to the fire at the outskirts of the fire
Yeah, well, that's
to
what
prevent that area.
Yeah.
Yeah, that technology, and I don't know if HFD used any drones in the Mililani fire or anything else. Barry, I don't know if you know any more about that, but yeah, I think drones can play at least with watching where the fire is going
Yeah.
and maybe preventing it.
Monitoring.
I think it's real important also to look at that lesson plan of what was established there, because later they moved the barrels or the water collection system up by the lychee farm that was above the residence area. So just wondering if that as a pilot program, an example, that they could do that in outlying areas above Pacific Palisades, all these other areas where they can establish an area where they could put those ponds so that they're well out of the reach of the residential area and schools and stuff like that. So that way it could be on a master plan where they would say if there's an outlying fire above Haleiwa or Pupukea, then these are the areas where we're going to put our ponds, so that way we're not drawing from an area within the community. Thank you.
Yeah, we've installed about 5 or so areas where we call them dip tank sites at our reservoirs at the very top. So we did one at the top of Makakilo. There's one in Makaha, Waianae. We're working on one in Lule. There's one in Nanakuli. We're working on one with Koa Ridge on the proposed reservoir that's on the Mauka side of H2. But for the Mililani Mauka fire, they did set up at our Mililani Wells 4 site, and that's well above the residential. And it's just to shorten the trips so they can get more water on the fire. But working with HFD, what are the key areas that we could add more? And that's the discussion we're having with them now. Because we provide the source of water for them to fight the fire, but they gotta be up in the air. So when it's too windy, they gotta wait for the wind to die down.
Mike,
So we got an island in the middle of the biggest pond in the world, or on the planet. Is salt water bad for everything? Can we use it some of the time? And if we're going to do ponds for freshwater access, what's a reasonable offset from the ocean?
We are meeting with HFD on Tuesday, I think, and we're going to be starting conversations about how to, correctly address, how can BWS support them in addressing wildfires. And I feel like this question has been brought up about using just ocean water, so I'll bring it up with them again just to see. It's a good point. Okay, so we've talked about the type of fire we're talking about. So as part of the AWIA risk and resiliency assessment we're doing now, we went ahead and had 2 models done. We call one the baseline, we call the other one the extreme. Baseline model is going to have typical wind and drought conditions seen when wildfires occur on the island. So, in Oahu's history, there's been several brush fires, wildfires. What are the typical wind and drought conditions during those events? Now, the extreme model are we have extreme drought and wind conditions, red flag advisory, if you want to think of it another way. Another way to think about it, too, are conditions for Lahaina, conditions for the LA fires. Extreme wind, really dry vegetation. Some of the model parameters that go into these, that it's common across both, are going to be the frequency, so the occurrence of wildfires that have occurred on the island. What we call community, we can simplify it as infrastructure that's on the island, or that's in the different communities. Severity, damage, so damage is mostly due to just structures, and then mitigation. Mitigation is going to be things like where is the closest water system, how close are hydrants, how close is the fire stations, et cetera. A big difference is going to be between the baseline and extreme is suppression. So suppression feasible means that the firefighters are able to address with their full capacity of infrastructure available. So that's going to be fire hydrants, that's going to be aerial support. In the extreme model, suppression is overwhelmed. Even, I mean, just, you know, seeing these responders in these extreme events, even just hoses is not as effective. You turn on that hose, you blow it at a fire, it's 30 feet that way, right? So in this extreme model, suppression is overwhelmed and not very effective. That's what we're modeling here. Okay, so let's focus in on this graphic a little bit. I'm first showing the baseline model. You can see that, this is Lahaina, right? This is what we're seeing here. The red bounds are gonna be the Lahaina fire boundary from 2023, the actual boundary. And we're showing the baseline model here. Low, moderate, and high, those are the different colors you're seeing here. We're talking about fire intensity, so how hot the fire is burning, according to the model. Again, this is baseline, right? So these are on Lahaina, on Maui, when fires occur, what are the typical wind, what are the typical drought conditions? That's what we're looking at. So what we want to do, and as you can see in the model, it's not capturing the obvious damage that happened to Lahaina, right? You're showing no risk there. All of the risk is basically surrounding Lahaina, right? Which is obviously not what happened in the extreme event. So let's now bring in the extreme model, what we're showing here. Just as a reminder, extreme fire weather, high winds, low relative humidity, and dry fuel from sustained drought. The fire is predicted to move faster and be more intense. That's important. So as Dave brought up before, these embers are being carried by the wind, these 70-mile-per-hour plus winds, and that is what is causing what we're seeing in the blue there, urban conflagration. Again, remember, that's that embers allowing buildings to be set on fire and then fire spread from building to building because of the high winds. So in the extreme model, we can see that it's capturing basically all of the damage that was done to Lahaina, right? So that's the basis that's why I wanted to show this, because it's actually predicting the damage that was done to Lahaina. I want to point out on the bottom right of the extreme, we have predicted urban conflagration. So I'll get into it in the next slide, but this is important to show that it predicted if a fire were to occur, let's say more southeast of where the actual fire did occur, that zone is at risk, right? So I think that's important to keep in mind when we see this next picture, because it could be a little scary. So we do the same extreme model. We're still looking at the extreme model here, but this is for Oahu now. We're looking at the same color scheme, low, moderate, high, very high, extreme, right? So the only extreme colors, which is that very bright red, you see some scatterings in the Ko'olaus, but it's mostly around the Waianae area, mostly. That's where the extreme fire intensity is going to occur. So the way this model is done, so these polygons are what we call fire sheds. These fire sheds have vegetation or just land use that allows the fire to behave in a similar fashion versus the other fire sheds. So in order to correctly capture the extent of the risk to the island, the model assumes a fire starts in each of these fire sheds. So that's why it kind of looks like it's all over the place. It's because the model assumes a fire can occur anywhere, because that's probably the most important thing to take away from this, is that we never know where this fire could start. It could start at any part of the island, and given the right conditions, given the right drought conditions, low relative humidity, high winds, damage could be anywhere. If we have a risk throughout, basically any part of the island is at risk almost, how do you fight that? What do we do? So that's what we're trying to do now. The second part of the risk and resiliency assessment is the emergency response plan. So our wildfire response plan is, most importantly, we need to coordinate with Honolulu Fire Department and the Department of Emergency Management on their current strategies and how BWS can most effectively help them. in their strategies. So we need to identify response actions for several different stages, let's say. The PSPS, which has publicly been out there, Ernie's presented to you guys on it, red flag advisories, and then if an actual scenario occurs, the urban conflagration scenario. And we need to highlight pre, during, and post-event actions in that plan to effectively fight the fire. So like I said, that's what we're starting on Tuesday. We're meeting with Honolulu Fire Department. It's the first conversation of many throughout this year that we're gonna have with them.
And about the responses and, you know, your readiness for wildfire risk as it pertains to insurances. As we know, the insurances are quite high nowadays, given, you know, some of these, you know, unfortunate events. And so by doing some of these measures to help support, you know, suppression and whatnot, do you know if the insurance companies, these underwriters of these massive companies, are taking anything of that into account as they underwrite, or is that effort, you know, kind of lost on them, you know, for some of these premiums? Because the property insurances are through the roof.
Mine
right?
too.
I mean,
Yeah.
you look at urban conflagration, I'm just like, oh my gosh, you know.
I can't speak to what they do or don't consider, but I will say, I think they are considering the frequency of these events is increasing, and that's probably why your property insurance is going up, because according to their models, they're seeing the same thing.
But do they consult with BWS though?
No, they don't come and talk to us. I mean, we do what we do because it's the right thing to do.
You know, the insurance commissioner's side, you know, I would hope maybe one day that they would take into account when the insurance commissioner speaks with you folks, there's some degree of stakeholderness to it all, right? So I would hope that they would advocate for us, you know, that BWS is making great efforts to help keep really bad catastrophes from happening. It's never going to be perfect, but they're doing more things to beef it up given what has happened in the past, the recent past. And so I'm really hoping that the insurance commissioner can help to kind of navigate some of this stuff with us, because it is kind of scary to think about some of these premiums and where are we going with it as it relates to some of these BWS efforts. Thank you.
They've never reached out to us or asked us, and I'm not sure, you know, I mean, again, Ray, you know more about our insurance than anybody, but yeah, that's a great idea though, Ryan, thank you.
Yeah, I mean, consolidated with fire department and Department of Emergency Management, you know, talking to them as a, because you get the whole picture, right? And maybe if they find, and even HECO, but maybe if they find that we're doing something about it, they won't leave the state like they did in California.
Yeah.
There's some really sad stories coming out about health issues that were related to people who fought those fires.
Yeah.
In your deliberations, does that surface as anything you folks talk about and consider?
Well, we're really focused on how BWS can address, and I mean, we want to ensure the safety of anyone responding, but I think really we're taking this perspective from, at least this plan, this specific plan, is about how BWS helps fight the fire.
So what I can tell you, Bob, is when we were working on the PSPS last year with a number of the city agencies and some of the state agencies, health and welfare of the people on the west side was very, very strong. We had DOH in the room, we had Y&I Coast Comprehensive in the room, we had several other nonprofits, and one of the outcomes of that is we literally went door to door to complexes on the west side, up in Waianae and Nanakuli, that work with seniors and people who are disabled. We talked about moving people out in the event of a fire, especially the medically fragile, people that have to use dialysis. So all of that went into the consideration set. And so I can't say that we solved all the problems, but we certainly put them out there and said, okay, these are things that we have to think about if something like that should happen.
We also looking at it, this is like where it's going to start and where it could be, right? Where are we vulnerable? The emergency response plan has to then look at, okay, so how are we going to fight the fire? How are we going to get the system back up and running? Because once a house burns down, it starts leaking water, and I think they said, the pressure goes down, but it could contaminate the system, as we saw in Lahaina, with backflow of contaminants, so how we deal with that, how do we test it? There's a lot of lessons learned from Lahaina. Department of Health had training on how to test the system to make sure that it's drinkable again, and they brought it back on. We had a meeting today with Hawaii Electric. We're trying to figure out how to fight the fire, right? They're trying, their strategic, emergency strategic plan is how to prevent it. So they're looking at certain circuits and how to harden them. And the high priority on Oahu was Makaha, Waianae, Lulule, Nanakuli, and Kahe. The power lines in those areas, how can they insulate them? How can they put in anti-spark switches and stuff, and underground whatever they can? So they are looking at trying to reduce the chances that the power system would start a fire. So attacking it from all these different angles. There's a lot that's happening, but it's really timely that we are working on this fire emergency response plan and putting it into the water master plan, because if there's infrastructure improvements that we have to build, if there's training for our operations staff, those things need to happen. So it's timely.
Because I don't know if you do, but are you a landowner? And are you looking at it from that perspective? Because I remember, I think one thing we all learned from Lahaina, and I think I read this, a former force federal firefighter said, is the fuel's the first part, right? So it's the owner of the land's responsibility to manage the quote-unquote fuel on your land. So are you looking at that as well?
But so we have fire breaks, vegetative fire breaks that we building in Makaha and Waianae in coordination with the state of Hawaii, the forestry guys, to slow it down, But that's just one line, For us, if we gotta go sickle grass down, bro, that's another.
Yeah.
Kaala Farms is working on a sheep pen to eat all the grass across the street, and we're providing a water meter for them. So there's a lot of efforts going on, and just understanding who's doing what and how can we facilitate and work together towards this, because it takes the whole community, right? Landowners and agencies, and being fire-wise, building codes as well, so that new houses are fire resistant. All of those strategies have to come into play, right?
We have meeting notes from last time. I know you all had a chance to review them. They got sent out ahead of time. Any comments or questions on those notes? Corrections? All right, we'll consider those accepted. Our upcoming meetings for the remainder of this year: Thursday, July 17th, and then Thursday, that date is wrong. It is not October 16th. It is the following Thursday. So 16 and 7 is 23. We're needing to change that because it's the conference of the Hawaii Waterworks Association, which is being hosted here in Oahu this year. Thank you all. Drive carefully, and we'll talk to you